So, good morning, ladies and gentlemen. Welcome back. This is our next lesson on trig and Cartesian plane from the package as provided. It might not be uploaded just yet onto the right space, but it will be later today. Hopefully everyone got this package. This first page is kind of a lot of content, so we just got to establish what's going on here. We have the Cartesian plane here, and the first thing we can talk about is angles and standard position. And at this moment, you don't know really what that is, so let's talk about it. Usually, from the origin, this red line is called the initial arm. So it's always along the x-axis towards the right. So it seems silly, but that's what it's called. It's called the initial arm. So a lot of teachers don't reference it, but there's a point to this because of physics. Some of you already know that you can change your bearings or change your rotations, right? So it actually matters. But in math, especially in functions, thank goodness, almost all of our questions are in standard position. So that's a good thing. But that's why we don't teach bearings, or I didn't get a chance to do that this year with us in the enriched math. Notice what I'm going to draw next. We need an angle of some sort. And again, from the origin, let's just say we have an angle in this quadrant. This arm, or the orange arm, is called the terminal arm. I think a lot of you can understand, since it's a straight line, any point that lies on this is going to form an angle, right? And so notice what I'm doing. This is the angle that we want. And usually we tend to use theta as our angle. And a lot of you are saying, well, what's the big deal out of this? Well, this is what's called angles of standard position, always with the initial arm. So we can draw another angle as a sketch, and let's put the initial arm still here because that's what it is. But let's put this angle like so, where the terminal arm is up there. And a lot of you can visualize already that this angle is, well, this angle is obtuse. This angle is acute. Let's just pause there for a second. Is everyone okay? A lot of you understand this like from grade 9. These are even a reflex angle, there's a straight angle, there's a right angle. But we're associating with the angles in standard position. But the main thing that I'm trying to get across for you at home as well, a lot of you actually can visualize a right angle triangle. And that's actually the key thing that I'm trying to show you. Some of you would argue, Mr. Chen, even though you said right angle triangle, I can see two right angle triangles. In grade 11, especially in MCR3U and 3U3, we're only going to talk about one particular right angle triangle. And that right angle triangle, we'll take the first example here. If we have a point that lies on this terminal arm, we're always going to make a right angle triangle with the x-axis. Everyone see that? So don't get me wrong, I will visualize it. Some of you say, Mr. Chen, why can't we take a right angle triangle like that? What's the big deal? We can solve it. It's not saying that you will get confused. Like the regular grade 11s will get slightly confused. In grade 12, we'll talk more about this angle that I'm pointing, but I don't want to stress it. And there is a relationship, and there is some formulas that we can use. And technically, you can solve things, but to make my teaching purposes a little bit easier, we're always going to make a right angle triangle with that point. Let's just pause here. Everyone okay so far? If we can construct a right angle triangle, then trigonometry is super easy, right? Especially for this one, right? In fact, let's put a point for this. That point could probably be 3, 4. Can you agree? So I'm now doing a specific one, even though this is a sketch. Let's say that point is 3, 4. Can someone please tell me this length? No pressure. What would that be? Tanush? Thank you. It's 3 units. And how about this length? Tanush? 4. Notice now with that point 3, 4, I think you can deduce what this length is. And Tanush is telling me the hand 5. Which of course in this example, it is the hypotenuse, right? So this is the famous 3, 4, 5, the Pythagorean triple, right? Notice in this example, let's just say the point was, and I'll do this one a little bit differently. let's say this point was -5 and 12. I know it's not perfect because it's just a sketch, right? So let's just ask the question again. This one's harder, but not that much harder. How can I draw a right angle triangle here? You just have to give me the instructions. Padina?
A line from the point to the x-axis.
Beautifully said. You wouldn't believe that some students are still like fighting over this. So we're always going to make a right angle triangle with this. Now notice the angle we want is this one, right? So don't get me wrong, we'll talk about that in a moment. And this one, this is a little different because we're using the Cartesian plane. This one's a little different, I apologize. You'll still give me the right answer, but it's also slightly incorrect. So let's just talk about it really quickly. So if that point is -5, 12, what's this like? Be careful. Be careful. What length is this? Ted?
5. 5.
It is 5 units, but that is not the correct answer. Would you like to try again? Sorry?
5.
Okay, hold on. So, don't care, he is, conceptually, ladies and gentlemen, he is right. I always get this answer. Everyone says it is 5 units. It is 5 units, it is. But with the Cartesian plane, we now have direction. So some of you that are taking physics kind of actually understand this a little bit better. So if you're not taking physics, that's also okay. This is 5 units, but I'm not going to write 5 units. Okay, sorry, is your hand up here? -5. That is -5. So you are correct. It is 5 units, but it's -1. How about this length? Jasmine? 12. I'm glad you didn't say -12. Because that's 12 units. Do you think you can actually calculate the hypotenuse of this right angle triangle? Jasmine again?
13.
It is 13. This is also a famous 5, 12, 13 one. And again, if you're not too sure how we got that, you can use Pythagoras. Notice that the radius or the hypotenuse is always positive. It's always going to be positive. So that terminal arm, if you want that length, it's always going to need that value. In fact, a lot of you know the equation from grade 10. Is that, right? Distance from the origin, that's that equation. Notice it's always going to be positive. I'm going to erase that because it's kind of neat. So there's a couple of schools that actually teach this differently, and we're going to explore them. So let's just pause the video, stop you here. This is an important lesson because everyone knows that this angle is obtuse, but I can't use this one just yet to find the angle that we want. Whereas in this example, this is acute, this one has no problem, right? So let's just stop this video.